Welcome back to Max with RP. Today we are going to be exploring the concept of increasing and decreasing functions. In great detail, we will see a lot of examples and then we will also see how to solve problems and find intervals of increase and decrease of a particular function. Now, first I am going to give you the definition of what is an increasing function. Then I will show you lots of examples. If x1 comma x2 are such that let f be a real valued function, okay, and if x1 and x2 are in the domain are such that x1 less than x2 implies f of x1 is less than f of x2 for every choice of x1 comma x2 in the domain of f, we say f is increasing. In fact, we say f is strictly increasing. If x1 less than x2 implies f of x1 less than, let f be a real valued function. If x1 less than x2 implies f of x1 less than f of x2, for every choice of your x1, x2 in the domain of f, we call f as an increasing function. In fact, we say f is strictly increasing in the domain that we are considering. So the very obvious function that you can think of is this: y equal to x. As x increases, you can see that y is also increasing. So here, whenever I choose any x1, x2 such that x1 is less than x2, f of x1 or y1 is going to be less than y2. Therefore, this is an example of a strictly increasing function. But it is also possible that you have a function which is strictly increasing like this, then it is constant for some time and then again increasing. Okay. In this case, you observe that here as x1 increases, y1, the y coordinate increases, but here it is a constant and then it increases. Okay. In this case, we call f to be an increasing function. F is an increasing function. So this is strictly increasing, this is increasing. Okay. Now, if let us look at the graph of some functions in GeoGebra. Okay, so I am going to type y equal to 2x plus 5. So you can see this is an example of a increasing function. Okay, y equal to 2x plus 5. How you can prove? I'll also tell you how you can. This is by looking at the graph itself. You can say for any choice of x1 and x2 such that x1 is less than x2, f of x1 is less than f of x2. But if you want to prove it algebraically also, okay, now if x1 is less than x2, okay, where x1 or x2 are elements of the domain. I have taken the entire R as my domain. Then you know that 2x1 is less than 2x2, which means 2x1 plus 5 is less than 2x2 plus 5. So x1 less than x2 implies 2x1 is less than 2x2, 2x1 plus 5 is less than 2x2 plus 5. So f of x1 is less than f of x2. Therefore, f is strictly increasing. I use this symbol for increasing, general common usage. So f is strictly an increasing function. Are you able to follow? Now we also should know what is the meaning of a decreasing function. So what is the definition of an increasing function? Whenever x1 less than x2 implies f of x1 is less than f of x2, we say it is strictly increasing. And if x1 less than x2 implies f of x1 is less than or equal to f of x2, we say f is increasing. So when you have x1 less than x2 implies f of x1 strictly less than f of x2, we call f as a strictly increasing function. If x1 less than x2 implies, right, f of x1 is less than or equal to f of x2, we say f is increasing. Now, if x1 less than x2 implies f of x1 is greater than f of x2, we call f as strictly decreasing function. F is said to be a strictly decreasing function. And x1 less than x2 implies f of x1 is greater than or equal to f of x2. We call f as a decreasing function. On the domain on which we are defining. So in this example, I have taken the entire R as my domain. Okay. Is it clear? Are you able to understand what is the definition of increasing and decreasing? How this is increasing by looking at the graph, and algebraically also how you can prove that it is decreasing. Now let us look at another graph. Okay. Now let me look at y equal to y equal to x cube. Now look at this function. What is this function? Y equal to x cube. Okay. Now you can see it is increasing throughout. There is a curve. There is a curve here, slight bend in the graph of the function. This is how the graph of y equal to x cube looks. Okay. There is a small bend in the graph, and then again it continues to increase. So this is also an example of an increasing function. Now I want to tell you about some property of an increasing function. See, what is an increasing function? x1 less than x2 implies f of x1 less than f of x2. Strictly increasing. Okay. In this case, now consider, okay, f of x2 minus f of x1 by x2 minus x1. Okay. Now, what sort of function is f? F is an increasing function. Okay. Therefore, f of x1 less than x2 implies f of x1 less than f of x2. So, f of x2 minus f of x1 is a positive quantity, and x2 minus x1 is also a positive quantity because x1 is less than x2. Now look at limit x1 tending to x2. When you tend x1 to x2, what is going to happen? I mean, x1 is not equal to x2, it's only becoming closer and closer to x2. Now, f of x2 minus f of x1 is positive. This is also positive. Therefore, this is a positive quantity. Okay, I can say therefore it's greater than 0. So, but what is this? Nothing but the slope. So, dy by, that's nothing but dy by dx. So, if f is an increasing function, its slope is positive and dy by dx is greater than 0 for a strictly increasing function greater than or equal to 0. Okay. Now, let me take a tangent from here. So, is it clear why in the case of an increasing function, slope is positive? What will happen in the case of a decreasing function? One will be positive or other will be negative. Therefore, slope will be negative. F dash of x will be less than 0. F dash of x is nothing but dy by dx. Okay. Now, let me look at, I want to draw a tangent. Okay. So, let me draw a tangent, say at here. I'm selecting the curve. I'm selecting here. I've chosen the tangent line. Select point or line. Okay, select point. I'm going to select this point. Okay, I want to draw a tangent at this line. Okay, so I got a tangent. So I got a tangent at a point A for this curve. What is the curve? Y equal to x cube. And what is the tangent line? Y equal to 3x minus 2. So if the tangent line is equal to 3x minus 2, what is the slope of this line? 3. So you can see that the slope is positive. Okay. But even otherwise, suppose I move this point. You just see, find out what is the slope. Okay. Or I can even use this. Okay. I'm going to find the slope. Okay. Now the slope is 3. Okay. Now I'm going to move this point. What happens to the slope? Slope is always positive. The function is increasing and you can see that the slope is always positive. So if f is an increasing function, its slope is positive. Okay. Now let us look at another function. Okay. Now I'm going to type y equal to minus x. Now what do you observe? This is an example of a decreasing function because as x increases, y decreases. So this is an example of a decreasing function. Can you see as x increases, how y decreases? Okay. Now let me draw one more curve. Y equal to minus x cube. Sorry. So this is y equal to minus x cube. One was y equal to minus x. This one is y equal to minus x cube. Okay. Now let us see what happens to the slope. So this is the tangent line. So first I need a point. Let me mark a point here. And I need a tangent line. Okay. I need to fix the slope. Okay. Now what is the slope? Minus 5.12. So y equal to minus x cube. You can also see from the graph that it is a decreasing function. It is like this. It's decreasing. As x increases, y decreases. Okay. And you can also identify by looking at the slope. Slope is what is appearing. M equal to minus 5.12 is the slope. M is the slope here. Slope is minus 5.12. Let me see what happens if I move this point. As I move, wherever I move, what is the slope? You can see it is negative. Wherever I move, it is negative. Okay, so y equal to minus x cube. What sort of function it is? It is a decreasing function. The slope is negative. If I draw a tangent at any point, the slope is always going to be negative. Now, let me type y equal to x square. Okay, I don't want this function. Okay, so I have okay, I have the graph of y equal to x square. Okay, now what can you say about this function? So if you look at minus infinity to 0, now look at minus infinity to 0. What do you observe? And what do you observe when you look at 0 to infinity? R plus. So here you can observe as x increases, y increases. Right? Here as x increases, y decreases. So here it is decreasing, here it is increasing. So if I take minus infinity to infinity or the entire real line, what can you say about f? F is neither increasing nor decreasing. F is neither increasing nor decreasing. Why? Because from 0 to infinity, positive numbers if I take, if x1 is less than x2, here I am choosing x1 and let x1 comma x2 belong to 0 comma infinity. Then if x1 is less than x2, f of x, you know that x1 square is less than x2 square. So f of x1 is less than f of x2. Therefore, f is increasing here. Therefore, f is increasing. Where? In 0 to infinity. Okay, let me choose some other color. Okay. Now, if I take minus infinity to 0, so that is this side. I am choosing values x1 comma x2 belong to minus infinity comma 0. Now, x1 less than x2, what will happen implies. Okay, what can you say about f of x1? x1 square, x1 is negative. Okay, for example, my x1 can be say minus 2. x1 can be minus 2. x2 can be minus 5. Minus 5 is less than minus 2. But minus 2 square, that is 4, is less than 25. So x1 less than x2 implies f of x1 is greater than f of x2. Or x1 square is greater than x2 square. You can give example and check if you want to verify. So, if you look at the entire real line, f of x equal to x square is neither increasing nor increasing. So, in 0 to infinity it is increasing, in minus infinity to 0 it is decreasing. Is it clear? Okay, now, so I'm going to give you a function and we are going to find out whether the function is, in which interval the function is increasing or decreasing. See, for example, I can have a function like this. Okay, now this point can be, say, minus 3, minus 2, I mean, sorry. Okay, you can see from here to here the function is increasing, then decreasing, again increasing, then reaches a peak and then decreasing. So it's full of valleys and peaks. So this is a peak and this is a peak. What is it going to imply? I will teach you later, but right now you can see that this is a graph which is increasing and decreasing. Increasing till here, decreasing, increasing, decreasing. Okay, now look at this function. Y equal to 10 minus 6x minus 2x squared. Okay, we are going to analyze this function. We are going to find where it is increasing and where it is decreasing. So for that, first let us find dy by dx. Okay, now suppose you have a graph like this. If I draw it, the slope here goes on increasing and then decreasing. Before it changes from increasing to decreasing, there will be a point where the slope of the tangent is 0. So here the slope of the tangent will be 0. That means it's parallel to the x-axis. Are you able to follow? So whenever a function changes from increasing to decreasing or decreasing to increasing, then when I draw a tangent, it is going to be parallel to the x-axis. Okay, that point is called critical point because that to the left of that is it's either increasing or decreasing. To the right of that critical point also it changes from increasing to decreasing or decreasing to increasing. Now let us look at this graph. Y equal to 10 minus 6x minus 2x square. So what will be dy by dx? Dy by dx will be minus 6 minus 4x. If I equate dy by dx to 0, step 1, equate dy by dx to 0. Then what do you get? Minus 6 minus 4x is 0 or 4x equal to minus 6, x is equal to minus 2 by 3. This means there's only one value x equal to minus 2 by 3 where the tangent to the curve is going to be parallel to the x-axis or where the slope of the tangent is 0. So if I take the entire real line minus infinity to infinity, the change of direction can only happen at x equal to minus 2 by 3. Change of direction means from changing from increasing to decreasing or decreasing to increasing. Now, I want to know in this, therefore, there are two intervals I need to consider. Minus infinity to minus 2 by 3 and minus 2 by 3 to infinity. Okay. I want to look at the nature of the graph, nature of the function in these two intervals, sub-intervals. So, how do I find out? What is this? What do we know? If dy by dx is positive, the function is increasing. If dy by dx is negative, the function is decreasing. Okay, so let me first look at minus infinity minus 2 by 3. This is the interval. Then let us see what is the sign of f dash of x. Then we will also see what is the nature of the function. Nature of f of x. Sign of f dash of x and nature of f of x. So between minus infinity to minus 2 by 3, I can choose any value and substitute here. Okay, let me consider x to be minus 5. Okay, definitely it is to the left of minus 2 by 3. Now what will be minus 6? F dash of x is minus 6 minus 4 into minus 5. So minus 6 plus 20, which is 14. So the function is increasing because it is positive. Slope is positive, greater than 0. So from minus infinity to minus 2 by 3, the function is increasing. I've already told you that if it is going to change, then there will be a critical point. And we have already seen there's only one critical point, which is minus 2 by 3. Now let us see what happens between minus, therefore, sign of f dash of x is positive. So what can you say about f? F is increasing. F is an increasing function in minus infinity to minus 2 by 3. Now let us see what happens between minus 2 by 3 to infinity. So let me take some other value, okay, and substitute in f dash of x. But I have to choose in this. In this, the obvious value that I can choose is 0. So let x be 0. What is f dash of 0? F dash of 0 will be minus 6, which is less than 0. If the slope is negative, the function is decreasing. So, in minus 2 by 3 comma infinity, the slope is negative and the function is decreasing. Function is it is increasing. So, your figure itself should indicate that. See, my figure, now I have drawn even the arrow mark. It is increasing. It reaches a peak at minus 2 by 3 and then it decreases. So, from minus 2 by 3 to infinity, it decreases. So, I think you have got an idea now. Today, we have just developed an intuitive notion about what is an increasing function and what is a decreasing function. This is a very favorite topic of mine, and I hope it also becomes a very favorite topic for you. Calculus is such an interesting and a very important subject in mathematics. So if you understand the concept, then you can never go wrong in solving problems, because if your conceptual understanding is very, very strong. So I hope you'll go through the content carefully and explore, and it is goodbye till the next video, which will happen very soon. Until we meet next time, goodbye.